Okay, so today we're going to be looking at section 7.3. We're going to be evaluating the trig identities. So, what is a mathematical identity? So, it's a mathematical statement that is always true for every value of x in the domain. Okay. In your material, I gave you this page right here. There's more trig identities. There's a bunch of trig identities, but these are the ones we're going to be dealing with the most. These are the ones that you're going to want to know how to use and be familiar with. I'm not going to require you to memorize these rules. You will be allowed to have this page on a test. So you do not need to memorize them, but you do need to know how to use them. Okay? And so we'll continually reference this page. So as you watch the video, make sure you have this page out so that you can look at the identities as I bring them to light. Okay? As I said right here, so you don't need to memorize them. You should. You'll learn most of them as you use them, but you need to know how to use them. We know the values of the trig functions for the unit circle. Okay, so angles on the unit circle, we know what those trig function values are, sine, cosine, and you should have tangent on it also. But we want to find the exact values of other angles, and to do so, we're going to need the trig identities to help us modify into the angles that we do know. Okay, so that's what we're going to be doing today. I have some journal problems we're going to be doing. We're going to be doing these journal problems right here. And let's just begin. So I'm going to write on a new page. So this is one that we did previously in an earlier unit. We know the cosine is equal to this. We know the angle is in quadrant 2. We want to find the tangent of the angle. So what we want to do is we want to have a representation, a picture of this scenario. Since the angle is in quadrant 2, let's draw a representative, let's draw some angle in quadrant 2. Okay? So that's the theta we're dealing with. And we want to drop the right triangle. We know the cosine is equal to that. So the cosine, which is defined as x over r, is given to us as a negative root 3 over 2. And since r is always positive, the negative is not with the 2. So r is 2 and x is a negative root 3, which makes sense because the x coordinates over here are negative. So this sign right here gives the representation of a negative root 3. R gives me a 2. And we need to find the y because tangent is y over x. To find the y, we use Pythagorean theorem. Negative root 3 squared plus y squared is 2 squared. And as we work this out, we find that y squared equals 1. So y is plus or minus 1. And so since there's two choices here, which choice matches what our scenario represents? Since y has to be a positive value, we're going to use the 1 for this problem. The positive 1. So this is 1 over here. If it was below down here, then the y would be negative, and I would use the negative value. So the tangent of theta, which is defined as y over x, then is 1 over a negative root 3. Okay? And we want to rationalize this. So remember, for rationalizing, we multiply the top and bottom by the square root of 3. So my answer will be negative, and I will get a negative root 3 over 3. Okay? And so there is how we find theta. Okay? And again, this is one we've done already in a previous unit. So why am I doing this one? Well, let's look at the next one. Almost identical question, but this time I want to find the tangent of 2 theta. Okay? But my information is based off of theta itself, not 2 theta. 2 theta is a different angle. It is not the same angle. So we cannot use, so we have to find a relationship that I can use that brings us back into single theta angles. So I can use this information. So it's the same information. Theta is in quadrant 2. Cosine is this. We already have it. This is the picture right here. and the values for x, y, and r. So I'm not going to redraw the picture for us. But how do I find tangent of 2 theta? This is where identities come in. I need to find a formula or an identity that takes the double angle, this is called a double angle, into a single angle. And so in your identity page, we look around for something that might be useful. Well, I have one right there. This is called the double angle formula for tangent. The tangent of 2 theta is that. So an identity member has been proven to be true for all values of theta in the domain. And so these are identical. This identity breaks this double angle into single angles that I can then use my information on. So we rewrite the formula down. Anytime I use a formula, you should always write the formula down so that you can see it and plug into it. A little side note here, what does this mean in doing our problems? A lot of times people make a mistake with this one. So here's a simple note that you want to include. Any trig function squared means that trig function, and the squared is on the outside. So you need to think about this as this, or rewrite it as this, so that you don't make mistakes in substituting into this formula. Now, up here we found tangent of theta. We know it's this, so I can use either this quantity or this one. You should be aware that they are both the same, because sometimes it's easier to do work with this form as opposed to this form. But you can use either one. Once I have the identity here, then I plug this value in for the tangents of theta. Tangent of theta equals that, so we're just doing substitution. So then I would write 2 tangent of theta, 1 minus the tangent of theta squared. So the tangent of theta we have up here is a negative square root of 3 over 3. You can also use that one, a negative square root of 3 over 3. And now we're just doing, order of operations stuff on this. So this up here will be a negative 2, the square root of 3 divided by 3. This right here, when I square it, is going to become positive. The top will become a 3. The bottom becomes a 9. So this literally just becomes 1/3. So now I have a negative 2 square root of 3 over 3 divided by 2/3. And hopefully you can see this as that's 2/3, that's 2/3, so they reduce out, and I'm left with simply a negative square root of 3. And that would be my answer. So this is kind of how we use this information and the identities to get to different angles, values for trig functions of different angles, instead of the one that I have. So let's look at some other kind of problems. So we have to find the exact value of the tangent of 75 degrees. So what is the tangent of 75 degrees? Well, this is not one of our unit circle angles. I need to find a unit circle angle that will help me do this. Now, there are several ways to do this problem, okay? One of which is this down here, the sum and difference. So let me explain this formula right here real quick. Here's the tangent of the sum or difference of 2 angles. So the plus and the minus. So this formula is actually 2 formulas in one. If this top sign is a plus, then this side, the signs that go with the top sign here is all the top signs. So if this is a plus, then I use a plus here, and I use a minus down here. If I'm subtracting 2 angles over here, then I will use the subtraction up here, and I will use the plus down here. So how can I use this? Well, I'm looking for 75. Can I find 2 of my unit circle angles that will either add to equal 75 or subtract to equal 75? And that's your choices. So there's a lot of different choices there on that one. The simplest one and the easiest one, obviously, is to do this one with 45 and 30. So the tangent of 75 is the tangent of 30 degrees plus 45 degrees. So I can do this as a sum. So in which case, then I'm going to use that identity. So again, you can reference the identity page to help see why I'm writing it this way. So this is going to become the tangent of the first angle, and whatever sign that is, it's the same sign, plus the tangent of 45 degrees over 1 minus, and then their product. So the tangent of 30 degrees times the tangent of 45 degrees. Okay? And so then we would go to our unit circle, and again, if you haven't done so yet on your unit circle, you should go around and write down the values of the tangent on the outside edge. So at 30 degrees, this right here is going to be 1 over the square root of 3, and this one's going to be a 1. So at 45 degrees, the tangent's 1. At 30 degrees, the tangent's 1 over root 3. Or you can write it as the square root of 3 over 3. I'm going to put parentheses, and 1 minus a product. 1 over the square root of 3, 1, 1 over the square root of 3, 1. And then you work this out. So looking at this, you can see I'm going to have a fractions inside of fractions. So I can multiply the top and bottom by the LCD, which is the square root of 3. And that will remove the inner fractions. So I distribute this, I'm going to get 1 plus the square root of 3, and then the square root of 3 minus 1. Now, a lot of times you can end right here, and I would be okay with it. But technically, this is not simplified because there is a radical in the denominator. So I'm going to show you how you have to go about getting rid of this radical in the denominator in case you've never seen it before. So, two terms in fractions, they're automatically in parentheses. You need to remember that too. Numerators and denominators are always in parentheses all the time. If you have more than one term and you're going to do something with it, you should always put it in parentheses so that you don't make any errors. The bottom has the radical. I need to undo that radical or move it or get rid of it. And so what we use is the concept of the difference of two squares. So if it's this minus 1, I'm going to multiply the top and bottom by the conjugate of this, which would be the square root of 3 plus 1, thereby giving me the product that results in the difference of two squares. This is the square root of 3 plus 1 on top. The bottom here, as I multiply this out, is just going to be the first number squared, which is 3, and then the back number squared, which is 1, and we subtract them. So the bottom here just becomes 3 minus 1, and you can distribute that out to see how that's done. These two quantities, although written backwards from each other, are identical. They're both 1 plus the square root of 3. I can think of it that way. And so when I multiply these out, just like any, binomials, it has a certain format. It's the first number squared, then their product times 2, and then the last number squared, which would be plus 3. So that's using the multiplication procedures there. So on top, I'm going to get 4 plus 2, the square root of 3. On the bottom, I get a 2, and then this reduces down to 2 plus the square root of 3. And that is your final answer right there. That's the exact value of the tangent of 75 degrees. Again, you could use other angle procedures. I put this one over here. You're going to need to add this one to your note page because it's not necessarily there. It's called the half angle formulas. And so I decided to include it. And right here, u divided by 2. So if I can find one of our unit circle angles cut in half that equals that, so 75 is the 150 degree angle, which is on our unit circle. So I can use that and I'll end up getting the same answer. So when you see something like this, you just choose one of these to use. You can use either one. You don't have to use both, just one of them. Same thing for the cosine of 2 theta. There's 3 options here. You only choose the one that most benefits you, depending on the information given. Okay, let's go on to the next one, number 4. In number 4, very similar to what we had before, it's the clues. So I give you the secant, and I give you a clue from the sign of theta is less than 0, and then we want to find these two things right here. For the sake of time in this video, I'm only going to do one of these, I think. And so how do I do this problem? Well, the clues have to find out the quadrant we're in and all that kind of stuff and get the information for angle theta. The secant of theta, and we know, and it's also an identity, that the secant is 1 over the cosine. So there's an identity right there. So the secant is equal to 2, which means 1 over the cosine of theta equals 2. Okay? And you can think of it as a fraction. And here's a little technique. If I have a fraction here equal to a fraction, you can flip both of them and you get this. So the cosine of theta then would be 1 over 2. Okay? And so then, because we already know this, we knew when we did it before that the secant and the cosine are reciprocals of each other. That's how we found the secant in the past. But this is using the cross multiplication technique. So where is the cosine positive? Cosine is positive in quadrants 1 and in quadrant 4. Where is the sine negative? Only in quadrant 4. So my theta is down here. So this is your theta. It's in quadrant 4. Drop your right triangle. The cosine is x over r. That means x is 1 and r is 2. Using Pythagorean theorem, we can find the y value over here. So 1 squared plus y squared is 2 squared. So that's a 4 minus 1 is 3. So y squared is 3. So y is plus or minus the square root of 3. And because we're in the quadrant 4 and the y values are negative, we're going to take a negative square root of 3. So this is the triangle I used for theta. So which one of these do we want to use? Let's do the cosine of 2 theta. So I need to pick an identity that I want to use. Since I'm trying to evaluate, I probably only have to deal with one trig function. So I probably will not choose that one that requires me to do 2. Either this one that uses cosine or this one that uses sine. I was almost given the cosine, so I'm probably going to use the identity that uses cosine. Okay? So then the cosine of 2 theta, here's the identity. Always write the identity down that you're going to use. And then I can plug into it knowing that the cosine is 1/2. So this is 2 cosine squared, remember, minus 1. The cosine is 1/2. And so then I plug in here, this is going to be 2 times, this is 1 over 4. This is 1/2 minus 1, so it's going to be a negative 1/2. And it's that simple. Okay? And you should use other identities to do the other ones. I got time to do one more. Let's do the sine one real quick. So the sine of 2 theta, and here's the identity, is 2 the sine of theta times the cosine of theta. So I need to take 2, find the sine of theta and the cosine of theta. The cosine of theta I know is 1/2. And then from my triangle over here, the sine is y over r, negative root 3 over 2. And so then as I multiply all this out, I will get a negative root 3 over 2. Because 2 and 1/2 cancel, it will become a 1. And this is my final answer. Okay? Number 5, this is the point on the terminal side. We've had all these kind of problems before. So again, where is negative 5, negative 1? Negative 5, negative 1, so it's a dot point here in quadrant 3. There's my angle, theta. This is negative 1, that's negative 5. I have to find r. So r squared is negative 1 squared, negative 5 squared. So now I'm looking at, this is r is going to be the square root of 26. So this is the square root of 26. Because r is always positive. You have to take the positive always. All right, so now this time I want to find the cotangent of 2u. So I'm sorry, this angle was called U, not theta. U. So I need an identity for this. There is no direct double angle for cotangent, but I know that the cotangent and the tangent are reciprocals of each other. So based off of that, all I have to do is flip this fraction over. So if the cotangent is 1 over tangent, and the tangent is this, then I just need to flip this over. So the identity for the cotangent of 2 theta is 1 minus the tangent squared of u over 2 times the tangent of u. If you look closely at that, you see all I did was just take the reciprocal of that for angle u. So that's how I get that identity. So what is the tangent of u? Over here, the tangent of u is y over x, so it's going to be 1 over 5. So then I just come over here and write out, so the cotangent of 2u is 1 minus the tangent squared over 2 times the tangent. So 1/5, 1/5, and we work this out. So this is going to be 1 over 25, so 1 minus 125 is 24 over 25. And this down here is 2 over 5. And as I flip this over and multiply, I get the final answer of 12 over 5. So that's how I can handle cotangents and other ones that are reciprocals. I can just invert or flip over any of the identities that are there. The last one right here we're going to do for this video is I gave 2 pieces of information. Both angles are in quadrant 1 and find a sum difference. Since I have 2 different angles, I have to have 2 different triangles, one for each angle. So in this particular case, so for the cosine of u, which is 3 over 5, and the angles in quadrant 1, it said, here is u in quadrant 1. X over r is 5, x is 3, we need to find y. Over here, we had the sine of v was 8 over 17. So v is the angle in quadrant 1. And that is y over r, so that's 17 and that's 8, and we need to find the x. So by Pythagorean theorem, 3 squared plus y squared equals 5 squared, you'll find that y is equal to 4. I'm saving some time in this video, just go with it here. And then over here, x squared plus 8 squared is 17 squared. And when you work this out, you'll find that x will be equal to 15. Okay, once I have those triangles built, all I have to do now is, what is the identity I'm going to use for u plus v? And again, write the formula down. Since I'm using the plus, I take all the, and that's on top, I take all the top signs. So that would be the tangent of u plus the tangent of v, 1 minus their product. And then I just need to plug into that formula. Okay, so what is the tangent of u? The tangent of u is y over x, so that is 4/3, here and here. The tangent of v is 8 over 15, so thus goes in here and here. So you want to find the common denominator. You can also use the calculator, just type all this in and get it into a fraction form. 15 is the common denominator on top. Okay, and then the bottom here is going to be, that's going to be 45. 3 times 15 is that. So this right here is going to be, if you work it out, this will be 28 over 15 on top. And down here, I'm going to get 1 minus And then this product here is 32 over 45. So let's clean this up a little bit. The top is still 28 over 15. The bottom now becomes 45 over 45 minus 32. And that gives me 13 over 45. And then I can flip the fractions and multiply, and I end up with 84, 13. And there you go. So these are the kind of problems you're going to be doing on the test. You'll have a couple of these kinds of problems on the test. You want to make sure that you know how to do the triangles for the single angles, and then picking the right identity and plugging it in properly for the others. So any other questions or stuff from this we'll do in class, and this ends the video.